This is the last problem from the Le Chatelier lecture that isn't really Le Chatelier. It's kind of, since this is the end of the unit, this is just a good AP question that kind of summarizes some things we did in the equilibrium unit. So I want to end the unit by working this out. So make sure you have that slide in front of you. I can tell it's not Le Chatelier because there's going to be zeros in the product side when we are in our rice table while we're looking at these guys here. So remember, Le Chatelier is just going to apply to when there's not zeros over there and the shift is not obvious. So I'm going to take that problem that it gave me, and we can set up a rice table here. All right, and we will copy it down. It's like we have ammonium hydrogen sulfide. That's going to go into equilibrium with ammonia. And hydrogen sulfide. Remember, I call him hydrogen sulfide even though he looks like he would be acidic because he's gaseous. And when acids are gaseous, we don't use acidic nomenclature. So there's a little flashback. Anyway, so one of the big things here that we've talked about a whole lot, and it actually has showed up in Schoology already, but I don't think I've shown you an actual problem, is the fact that we have a solid here, all right? So what I've mentioned to you previously in lectures is that if something is trying to go into a rice table that cannot go into equilibrium, like solids and liquids, then we can just X out the information below him, because for equilibrium, he's going to just be ignored, all right? And then, again, if you read the items that are given in the problem, you'll see that our initial concentration of both product is going to start at 0. So using our normal shift here, you'll see that we expect our products to both, of course, go up. There are no coefficients, all right? So we don't have any coefficients to drop. So that's what our change will look like. Therefore, both of them, remember for E it's I plus C, so both of them will be 0 plus X, which is ultimately just X. The question wants to know what is the equilibrium concentration of these dudes. So in other words, it wants to know the X value, so they're going to have the same equilibrium concentration since their change is the exact same. So we can begin to plug and chug. So my unsubstituted equation then, as we find Kc, is going to look like this. Put my products over my reactants. Now, here's the issue though. All right, remember, this solid dude cannot go into here. All right, anytime that happens, anytime something can't go in, we just replace it with a 1 as a placeholder so that the rest of the math, the rest of the calculation will still make sense. So really, we don't even need this over 1. I mean, we could just write this because, anything over 1 is itself. So really, the unsubstituted equation could just be Kc equals the H2S and the NH3. I don't know why I've inverted those. I'm sorry. But they're the exact same for the expression, right? So this right here is ultimately my unsubstituted equation. It's okay if you leave it over 1. It's not wrong. It's just I think the math looks clearer in your brain if you do it like this. All right, so now we can substitute in. Now, if we go back to the problem, you'll see that it does give us a K value, right? It says Kc is the 1.8. And we know that usually being given K is bad news, right? But you'll see that this time it's a little different because of this solid. So I'm going to I'm going to plug in. So the Kc is 1.8 equals the H2S is X, and the NH3 is X. Oh, I shortened this, didn't I? It's 1.8 E negative 4. E negative 4, it's okay, I'm about to simplify it. So if we simplify this, it ultimately is 1.8 E negative 4 equals X squared. All right, and now it's not a quadratic since because the denominator there was a 1. Now I just have to know how to solve for X, and hopefully you know that if X is squared and you need to solve for it, that you just need to go and find the square root. So in other words, if I find the square root of that, it will undo the X squared. So I'm going to say square root of 1.8 E negative 4 is going to give me a final answer of 0.013. All right, so that solved part A of the problem here. All right, and I say part A because if you look at what we're doing, there's an A and a B. So that actually solved for him and him. All right, well, what if we do that next part? And what this is going to do is it's going to give us an initial concentration of one of the products. All right, it's going to give us moles over liters, so that's a molarity of the NH3, the ammonia. All right, so it's the same, almost the same rice table, except when I do I'm going to go straight down using the same reaction, so we can just do ice. So we'll still be X'd out there, of course, but my initial concentration of the NH3, it says, is 0.02. It's going to be 0.020. We still have 0 of him, all right? This will still be plus X and plus X, because again, we're going straight down, all right? We're still using the same reaction. So, but now you'll see that it's 0.02 plus X here and just X there. So my unsubstituted equation here is still correct, right? I mean, it's still over 1, but we can still use this for our plug. So this is the unsubstituted equation, but now our values are a little bit different for each of the dudes. So let's plug and go. So now the Kc, of course, is still going to be 1.8 E negative 4 equals, all right, and then we'll go, I wish I didn't invert these, but whatever, H2S is just going to be X, and NH3 is going to be 0.020 plus X. So when we multiply these, there'll be a distribution, right? The X will multiply there and there. And now we can see the example where K is given and a quadratic's going to form. Because I'm going to get 1.8 E negative 4 equals 0.020X plus X squared as the X distributes. For our solver to work, to solve this quadratic, it needs to be a 0 equals. Now, you'll notice that these two guys are already on the same side. And remember, we never want the X squared to be negative. So I'm going to rearrange this a little bit and bring him just over to this side so it looks correct. But then I need to subtract him to move him over here. All right, so in other words, as I move it all around, it'll say X squared. All right, this is positive, so plus 0.020x. All right, take the opposite sign to move it over here, minus 1.8 E negative 4. And now I've got my quadratic all set up. All right, so let's go for that. All right, if we remember what to push here, we're going to go math and then go down. I cheat by going up, but go to solver. There's my 0 equals. All right, so I'm following right down here. 0 equals alpha to get to the x, and then squared plus 0.02 alpha to get to the x again, minus 1.8 E negative 4. It'll take me to my intermediate guess screen. I always pick 2. Then I want to go solve, which will be alpha enter for me, alpha solve. And it looks like I'm going to get a value of x equals 0.0067. All right, so that will be the x value there, right? So this is going to equal the concentration of H2S. All right. Of course, to find the concentration in part, remember, because we are doing part B here, to find the concentration of the other guy, we want to plug into here, which will be 0.020 plus x 0.0067 is ultimately going to equal 0.0267, which will be the concentration of ammonia.